told you in the last video that stress is proportional to strain. It turns out this is true for many fluids, such as water, but it's not true for all fluids. The fluids in which stress is proportional to strain is known as a Newtonian fluid. But there are many non-Newtonian fluids around, and I'd just like to spend a little while talking about how these non-Newtonian fluids behave. We can represent variations in the relationship between stress and strain using a stress-strain diagram, in which we plot strain on the x-axis and stress on the y-axis. Of course, a straight line on this diagram passing through the origin is just a Newtonian fluid, where the slope of that line indicates the viscosity. High viscosity means a large slope, so that stress is large even for small strain. Think honey rather than water. But there are fluids which actually get more viscous if you stir them more. These are shear thickening fluids, and you could actually make this at home by mixing cornstarch with water. Other fluids do the opposite. They become less viscous as they are strained, and these are shear thinning fluids, including paint, which helps them to coat surfaces evenly. Some fluids have a yield strength, meaning that unless you put a certain amount of stress in, you will get no motion, and once they move, the stress continues to rise with strain. Plastics sort of behave like this, but so does tomato sauce, which you might know about if you've ever tried, unsuccessfully, to completely empty the sauce bottle. These are often called Bingham fluids. Simply put, there's a pretty wide range of interesting material properties that I would love to explore with you more if I had time, but we don't have time, so just by way of example, I'm going to take a quick look at putty. First, we're going to roll this putty into a ball and balance it on a container. And then we're going to leave it for hours and hours and take a time-lapse video of it. This is sped up by about 100 times. After some time, I don't think I have to work too hard to persuade you that this is actually behaving like a strongly viscous fluid. But it turns out that this fluid is sort of shear thickening, in the sense that if I hit it with a very fast impulse, its viscosity increases. In this case, it actually acts more elastically, so a slow motion film of our putty hitting the table shows that it bounces like a tennis ball. As much fun as materials like this can be, I'm going to return to Newtonian fluids for the remainder of this course.